real important thing here, the takeaway point is a fairly high percentage of your writes are no longer having to go to storage. It's not that you're not doing as much work. You're just now doing it smarter, more logically organized. You're doing it in larger, more sequential IOs than these haphazard, random, tiny, fractured IOs. And each of these IOs takes time to complete. So the more IOs you do, the longer it's going to take for that transaction to complete its task. So if we're able to eliminate, 30, 40, nearly 50% of the writes from having to go to storage, an interesting thing happens here. However you write the data is how Windows is going to read it back. So technically, this IntelliWrite functionality is providing a benefit on those initial writes and any subsequent reads. Now, we can take that a step further by identifying and leveraging free, idle, unused memory on that particular Windows guest VM, or if it's a physical Windows server, that's fine too, or workstation. But a Windows system that's no longer or not using all of that available memory, we can temporarily borrow a portion of that memory to act as a repository for our repetitive read cache, where we identify the same logical blocks that are being read over and over and over again. It doesn't make sense to keep kicking those out and going all the way to storage if you have memory that we can put a copy of that data and now have Windows retrieve the data directly from memory. It no longer has to send that read IO request to storage. And because that data is being recycled or being read multiple times, it's getting satisfied at the speed of memory. Memory to memory data transfers are like 12 to 15 times faster than going to flash or SSD. And your backend storage is getting the benefit that it didn't have to waste its precious time even worrying about or processing that request. The storage system can now focus more of its attention on the IOs that do have to go to storage, those writes and non-repetitive reads.